My name is Prasia Jackson. Today we are here with Brad Brown, the professional engineer at Brownfield Environmental. Hi.
Hello, how are you today?
Good, how are you?
I'm great, thanks.
Tell me about what a typical day looks like as a professional engineer.
That's a good question. I'm not sure there is any typical days, but a lot of what we do is we're helping our clients and our customers solve problems that are technical in nature and environmental in nature. So that could involve doing a permit for an asphalt plant, an air permit, doing a stormwater permit for a construction site or a mining site.
What is your specific part in the process of the stadium?
In the process of the stadium, this is a really exciting project, and I've got a little image up here. What we see, with the stadium coming out of the ground and being an actual live project now, it's pretty exciting to see all that stuff. But as the environmental guy, we look at what's happened there over the last 100 years. So on this site, in the beginning, back in the 1800s, there was a stockyard there where animals were housed, and before slaughter, there's railroad tracks that came through there. There was an oil company that stored bulk oil and fuel products, and a manufactured gas plant where they cooked coal, and they captured the gases that came off of that, and they used that to heat houses, and street lights used that gas. So all of those things basically contributed to the history of the site. So what we used to see before the stadium project started was a nice grass field, but really what was underground was a lot of skeletons from old buildings, contaminated soil. Back in the 1800s, the early 1900s, we weren't great stewards of our environment. We left a lot of soil contamination in the ground. We did things that buried tanks and different stuff, and things leaked, and all of those things, they have impacts on stuff. So that's where we came in and managed, the environmental risks, so that we didn't expose any of our people that are working out there, the guys that are digging in the ground and in the ground laying the pipes, that take care of the water that's coming into the site, the sewer and all that kind of stuff. So that they weren't exposed to anything. And there's some soil contamination, but we've managed that. We protected the workers, and made sure that they were implementing all the things that they needed to do so that they weren't exposed to any of those chemicals or anything. And then the biggest part is to manage the soils and all the materials that come off of that site, so that any of those soils, the clean soils, they can go to a spot for clean soil, but there's a lot of soil that had to go to a landfill as well. And of course, to make sure that nothing got into the river, none of the storm water got into the river. We had to do some dewatering there, where they pumped out the water to lower the groundwater table to install some of those utilities, and we made sure that none of that water was contaminated that was pumped into the river or anything like that. So it's an exciting project for us.
So then are you guys being put at risk if there is any contamination in the water, like anything underground?
So we know that those risks are there, and one of the things that we did ahead of time was we went out and took soil borings and water samples in many places throughout the project, and to determine that kind of thing ahead of time of what to expect, so that when the workers came to do their work, we had a pretty good idea where the soil was contaminated and what we might encounter. And then we used a couple meters. It's one called a photoionization detector that measures the off-gassing of the soils. And once it got over 5 parts per million, then we would have the workers use a respirator, so that they weren't breathing any of that kind of stuff.
Did you always plan on doing this?
Absolutely not. When I was a senior in high school, I was actually not even planning on going to college. And my mom really pushed me a little bit, and somewhere along the line the light bulb went on, and thought maybe that's a pretty good idea.
Mm-hmm.
So I went to college and I got a degree in civil engineering, and it's been the best thing that I've ever done in my life. It opened up so many doors career-wise to give me a lot of different opportunities.
So then overall, what education is required to get to the position you're in today?
So the engineering degree, that opens up the door to be a licensed professional engineer. So what exactly does that mean? So you have to go to an accredited engineering school, get the degree in your field of engineering, and then you take a fundamentals of engineering exam right when you get out of college, and it's an 8-hour-long test. And then 4 years later, you take the professional engineering exam, and then you can be a licensed professional engineer. So I'm licensed in the states of Illinois, Wisconsin, and Iowa.
Have you ever worked on a stadium before?
Not on a stadium, but I've worked on many sites that are similar to this, which are big construction projects and that have lots of soil contamination and groundwater contamination, and a lot of our projects are built in nice green areas that are pristine. And there used to be a cornfield last week, but when you're working in the downtown urban areas, there's a lot of different things that are in the ground because we've used that site for many things over the years.
Right. How would you suggest that someone get started in this job to get to where you are today?
Any of the the degrees in environmental science, biology, engineering, environmental engineering, civil engineering, they all have a great background with the technical and science aspects of the skills that are needed. So we use a lot of our engineering and science to monitor the type of chemicals and our knowledge of that type of thing to know what the contaminants are, how contaminants travel through the soil and into the groundwater, and to know how that stuff works. So any of those fields that are environmentally technical would be a great venue to get into the stuff that we're doing.
And then do you guys here offer any apprenticeships or internships?
We do. We've had several environmental interns that have been with Beloit College that have worked for us in the summer, and a couple of those have turned into full-time employees. A couple of them have went on to grad school afterwards, but we definitely offer internship opportunities.
And then would you say there's a specific personality type or person that fits this job?
One of the things that's important, and we look at our different skill sets of we talk about the science and technology and the math, and so we certainly have to be versed in those fields, but equally important is our communication skills and how well we can communicate with other team members. Like for the stadium project, for example, we had to take our technical knowledge of the soil and the groundwater and be able to work with the team of folks that's actually building the project and communicate those things so that they can incorporate all that into how they're going to actually build the project, how they're going to manage it cost-wise, and how they can anticipate dealing with all those things.
Could you tell me a little about what we're looking at right here?
Absolutely. So this is the proposed Riverbend Stadium, which is well under construction right now. The main part of construction, if you go by the site, is the building, which is coming up on the southwest corner. And interestingly enough, that's also where a lot of the soil and the groundwater contamination was at, right down in that area. And that's also where we had to do some of the deepest footings for the excavation on the building and some of the infrastructure. There's a sanitary line that came along this way and also ran up along the river, and that's where we had to do the dewatering that we had put in the well points. And so we tested that water to make sure that it was clean before we pumped it out into the river, and those areas were clean, so we were able to do that. And we tested that water, monitored it daily, and took samples every week to make sure that it was clean during that process. So our team of folks that we've had on the stadium project, we've had a couple of our environmental project managers that are out there on a daily basis monitoring the working conditions that the workers are in, monitoring the air quality to make sure that there isn't any dust leaving the site that's got contamination in it from the soils or anything like that. We've had a dust meter out there measuring the contaminants in the dust every single day, and our environmental technicians are there monitoring the worker conditions, documenting where they're working, what the conditions are, and making sure that nobody's getting exposed to any of the contaminants in the soil. And my role then as the professional engineer is to oversee all that. We've made sure that the workers are properly trained and knowledgeable about working in hazardous environments with hazardous materials, and our people are trained in that as well to oversee that and document that.
So what is the process you have to go to in order to take a soil sample?
So if we're going to go out on a project and do some soil sampling, we'll often use either hand methods where we dig a hole ourselves, or we'll use a drill rig which pounds a tube down in the ground and it pulls out a soil sample, so we can get down at depths greater than what we can dig by hand. So we can go down 30 and 40 feet and take a sample, and we can screen the soil all the way down through that length of what we're looking at. So for example, on the stadium project, we took borings to about 20 feet below ground surface, and then we would screen the tube of dirt. We would use what's called a photoionization detector, or PID. And what this does is it measures the off-gassing of VOCs in soil. And I'll demonstrate how this works. This is a Sharpie, and we've all smelled the odor that comes off of a Sharpie, right? Well, as we screen the odor, the VOCs that are giving off on the Sharpie, we can see our meter is going up. And give it a second here, it's probably going to go up to about 20, I'm guessing. Maybe not, this is an old Sharpie, but you can see the numbers are going up. Normally it's 0, there's usually not any VOCs. So yeah, now it's getting up there. Yeah, and hey, there's some VOCs in this stuff, so don't breathe the Sharpies. That's the takeaway lesson. So we screen the soil with the PID, and that tells us, it's a field screening tool that shows us where the greatest concentration of contaminants are. And then we would take, a soil sample, and we would put it in a 4-ounce jar. We'd label the jar with the sample number, when it was taken, the date and the time, where it came from. Then we also use vials, and these have preservatives in them. And typically, we've got 3 vials. This one contains methanol and sodium bisulfate for both of these. Because what these do is preserve the sample so that when the lab gets it, it's exactly how it came out of the ground. So it's not losing any contamination along the way. So we put a measured amount of soil in here. You can see the liquid in there. And we use a syringe, basically, and we put an exact amount of soil in. We just push that into our sample. If we were taking a soil sample, we'd have a bag, usually put it in a Ziploc bag, and then we take the sample out of that and pack it in here and put it into our vial. And then we put the soil samples on ice in a cooler and ship them by overnight courier to a lab. In Wisconsin, we use the lab up in Green Bay, and so they get there the next day, and they have to be controlled at a temperature that's 8 degrees Celsius, and then they're preserved, and the lab does their work and gives us a nice report back and tells us what we have for contamination. And then so the lab knows what to analyze for. We fill out all of this. This is called the chain of custody. So it has our information on, so they know who sent the soil sample, when it was taken, exact time, and what the analysis is that we're looking for. And they send us our nice reports and it tells us if we have any soil contamination or not.
What happens if the soil is not kept at the temperature it needs to be at?
So that's a really good question as well. So if the soil isn't kept at the temperature it's supposed to be at, like if it's warmer, and one of the things we run into is if we take a sample on a Friday and we ship it off normal Federal Express overnight, and guess what? There's nobody there on a Saturday and it doesn't show up until Monday. All that nice ice that we put in the cooler has water on Monday, right? So the sample is higher, and so the VOCs that we were talking about, at a higher temperature, more of those will off-gas over time. So there could potentially be less contamination in that soil than what there actually was when it was sampled.
Thank you so much for your time. I'm glad I got to learn about the process of being a professional engineer, and I hope others are interested in it too.
You're very welcome. It was my pleasure, and I enjoyed sharing with you. If you ever have any questions or anything, feel free to come back and we'll talk some more.
Thank you. Thank you guys for watching. If you have any interest in being a professional engineer, contact CareerTalk or Brownfield Environmental Engineering.